Next up we have section 2.2 on elementary functions and their transformations. So behind me I have 6 elementary functions that we'll start with in this class that you should absolutely know and sort of know by heart. Just be familiar with what their general graphs look like, because you'll work with them all the time, and I promise you that as you go throughout mathematics classes, life is a lot easier if you have a general feel for just if someone gives you a function, if you have a general feel for what its graph looks like. And that's our goal with this section, is to be able to identify pretty quickly the graphs of various functions. So we're going to start off with these six that you should know. Our first one is f of x equals x. So of course you should recognize that as being a straight line. It's of the form mx plus b, where m is 1, b is 0. So it's a straight line graph with slope 1 through the origin, right, through with y-intercept 0. So there's y equals x, sometimes called the identity function. We've got f of x is x squared, so y equals x squared. This is a squaring function. You plug in x and you get out the square of x. So the graph of it is this nice parabolic shape, passes through the origin there, and slopes upwards pretty steeply on both sides. Number 3 is f of x equals x cubed, the cube function. You plug in x, you get out the cube of x, and the graph looks like this. It's sort of this squiggly shape. We've got the square root function. F of x is the square root of x. You plug in x, you get out the square root. And I want to note here that notice that the domain is only from 0, including 0, so I've got this filled in circle here because you're allowed to plug in 0. It's from 0 to infinity. I'm not allowed to plug in any negative values, right? So this is why the graph looks slightly different than the others, is the domain is strictly from 0 to infinity. But the square root function looks like this. It increases pretty quickly in the beginning, and then it starts to increase less quickly as x gets bigger and bigger and bigger. We've then got the cube root function, which looks a bit like this. Again, this squiggly shape that don't really know how to describe this. It looks a bit like the cube function, but on its side. And last but not least, f of x is the absolute value of x. So the absolute value function, it for positive values of x, it looks like y equals x has slope 1, but for negative values of x, it actually looks like y equals negative x. So it then slopes up in the opposite direction. So these are the 6 functions we'll be working with in this section. We'll be performing what's called transformations on these functions. But it's the 6 that you should know by heart. You should be familiar with what their graphs are. If I were to erase this board and say draw the graph of the cube root of x, you should be able to do that. Okay. Okay, so now we're getting into graph transformations. Our goal here is to take what we know about those 6 simple graphs and use them to produce graphs of new functions. So our first transformation is of this type, y equals f of x plus k. And what this does is this takes the graph of y equals f of x, so hopefully that'll be something known to us, and it shifts the entire graph up, all the y coordinates, it shifts the entire graph up by k units. So we start off with y equals f of x, y equals f of x plus k, the graph is the same thing, but shifted up k units. So it's a vertical translation, and if k is positive, if we're adding a positive value, it shifts it up. If k is negative, it shifts it downwards. So for example, let's say someone says graph y equals x squared plus 2. Well, I know how to graph y equals x squared, right? Here's y equals x squared. There's the graph of y equals x squared. How do I know that? Well, it's one of our 6 simple graphs that we just commit to memory. Right, so there's y equals x squared. Now I'm going to perform this transformation. I'm going to, what are we doing? We want to go from y equals x squared to y equals x squared plus 2, and I know that just adding a constant, adding plus 2, is going to shift my entire graph up 2 units. Right, so what's my base? I'll usually think of shifting the origin in particular. So we pass through 0, 0 in this graph. Now, if we shift it up 2 units, we'll be passing through 0 and 2. And the entire graph just gets shifted up 2 units. Right, so this is the graph of y equals x squared plus 2. And that's all there is to it, right? This is really nice. This is all you have to do. If someone says graph this function, you just say, well, I know what this looks like. This looks like the graph of x squared, but I shift the whole thing up 2 units. And that's all there is to it. We'll do one more example. Okay, so now I want to graph the square root of x minus 1. Well, we'll start off with our simple graph. We start off with square root of x. Again, how do I know this? Well, because it's one of our simple graphs that we have memorized. And I know what I want to do to graph square root of x minus 1. I want to shift the whole thing down 1 unit, right? So this transforms into, again, this point here was the origin. This is at 0, 0. So if I shift it down 1 unit, it should be at 0 and minus 1. And we'll just draw the same shape, but starting at 0 and minus 1 instead. So this is roughly the graph of the square root of x minus 1. So far so good, but what we're going to do is we're going to introduce more types of transformations, horizontal shifts, reflections, and when we start combining them it gets a little bit more interesting. So let's move on. Let's do type 2. So here's type 2. Instead of adding a constant to the entire function, instead of f of x plus k, right, f of x, close brackets, plus k, here we're doing something slightly differently. Instead of having f of x, we're replacing x with f of x plus h. So everywhere you see x, you replace it with x plus h. And what this does is this gives us a horizontal shift of the graph. And I want to point out that this unfortunately doesn't work the way you think it does, or the way your intuition tells you immediately that it should. It's the complete opposite, and I always have to remind myself of this. So if you just remember that it works the opposite way as you want, that will suffice, because adding a positive number, so plus h, is a shift to the left. Usually you'd think of plus would be to the right, but it's the opposite here. So adding a positive number is shifting to the left, and then subtracting is a shift to the right. So for example, graph, let's see, what do I have? Let's draw the graph of y equals x minus 3 cubed. So you'll look at this and you'll say, okay, I'm going to start with the graph of x cubed, and then I'm going to replace x with x minus 3. So that gives me a horizontal shift. So I start off with x cubed, which I know looks roughly like this. Here's y equals x cubed. And now I'm going to apply this transformation. So this will be x minus 3 cubed. And again, I know up here what this type of transformation does. Replacing x with x minus 3 is a horizontal shift, and because I'm subtracting 3, it's a shift to the right. It's a shift to the right 3 units. So once again, I'm going to start with the origin here. I know it passes through the origin at 0, 0. So if I shift this to the right 3 units, this origin is going to go to 0, x coordinate, 3, 0. And now I just have to draw the exact same shape, the exact same picture, but with my origin shifted. So this graph should look like this. So it's a rightward shift 3 units. Let's see, let's try another one. Okay, so I start with the absolute value of x, right? I know what that looks like, because it's one of these that we just commit to memory. So there's y as the absolute value of x. And now you'll notice I want to do 2 different things to this. I want to replace absolute value of x with absolute value of x plus 2. So I want to replace x with x plus 2. to get our first transformation. So let's do that. And it actually doesn't matter which order you go here, but I'm going to do the horizontal transformation first. So first thing we'll do is replace x with x plus 2. So this will be the graph of y is the absolute value of x plus 2. So if I replace x with x plus 2, that is a horizontal shift. We're adding 2 units, so that's a shift to the left 2 units. So the origin here at 0, 0 shifts to minus 2 and 0. Okay, so this becomes the same shape, but moved over to the left 2 units. So there's the graph of absolute value of x plus 2. Now, I want to take this whole graph, y equals absolute value of x plus 2, and add 5 to it. So that shifts the whole thing up 5 units. And that'll be the end of the game here. Take this graph, move it up 5 units. So this point here that was at the bottom of this valley at minus 2 and 0, that shifts up 5 units to minus 2 and positive 5. So that whole thing shifts up 5 units. Shape stays the same. And there's the graph. Y is the absolute value of x plus 2 plus 5. So slightly more interesting now that we're combining horizontal and vertical shifts together, but we're going to do even more than this. Here's our third transformation. We take our entire function, y equals f of x, and we multiply the whole thing by minus 1. And what does that do? That gives us a reflection of the graph through the x-axis. So, oops, I put my minus in the wrong spot here. So here's the example. Let's draw the graph of negative cube root of x plus 1. So again, you'll see the part that we're familiar with. We know the graph of cube root of x, so let's start with that. Cube root of x looks roughly like this. Y is the cube root of x. And the first thing I'm going to do here is I'm not actually going to apply the plus 1. It sort of matters which order we go when we start multiplying things by minus and whatnot. So here first thing I'm going to do is take my cube root of x and make it minus the cube root of x. Because then I just have to add plus 1, which is going to be a vertical shift. So first thing we'll do is we'll transform this to minus the cube root of x. And what does that do? What does multiplying by minus 1 do? Well, up here, as we've said, it's a reflection through the x-axis. So imagine I just sort of take this whole graph and I reflect it over. Everything up here becomes reflected down here, and vice versa, everything down here becomes reflected up here. So if I reflect over, if I take all these y values and make them negative, the reflected graph should look something like this. There's negative the cube root of x. Right, do you agree? If I took this part and I reflected it over, I would get something like this, and if I took this part and reflected it over, I would get something like this, which is precisely the shape I'm trying to draw over there. And yeah, so now we have, because we know the graph of the cube root of x, we know by this transformation the graph of minus the cube root of x. And all I have to do now to get minus the cube root of x plus 1 is shift the whole thing up 1 unit. So we'll shift this origin here to 0, 1, and we'll just draw the same shape, but shift it up. So there's minus the cube root of x plus 1. Oops, minus. So throwing a minus sign in isn't too much extra work. You just have to reflect your picture through the x-axis. Okay, so our last type of transformation is, instead of taking your entire function and multiplying by minus 1, here we're just going to multiply by a positive constant. So you have a times f of x. And this corresponds to a stretching or a shrinking of the graph vertically. And when does which case occur? Well, if a is a positive value bigger than 1, you get a stretch. Meanwhile, if a is a positive value between 0 and 1, then you get a shrinking. So for example, let's draw the graph of y equals 2 times the absolute value of x. And I think I'll overlay this here. I'll overlay what's happening here. So there's y is the absolute value of x. I want to draw y as 2 times the absolute value of x. Well, that's 2 is bigger than 1, so we have a vertical stretching. And the way you should think about this is literally what's happening. We're taking all the y values and making them twice as big. Right? Instead of being the absolute value of x, they're going to be 2 times the absolute value of x. So all of the corresponding y values here become twice as big, and if I stretch this vertically, we get a picture like this. All right, literally think of grabbing this picture and stretching it up vertically to get the graph of y is 2 times the absolute value of x. Meanwhile, if I said, let's draw maybe 1/3 times the absolute value of x. Well, now I take the absolute value of x and I make all the y values 1/3 as big as they used to be. So 1/3 is between 0 and 1, so this is a vertical shrinking. I'm taking this picture and I'm vertically shrinking all the values by a factor of 1/3 in this case to get a picture like this. So there's y is 1/3 times the absolute value of x. Full disclosure, this fourth case, in the grand scheme of things, not as important as the other three, but this is a really useful skill. I didn't appreciate this when I was first learning this myself as a student, but as you go through math classes, it's really, really, really useful to have a good idea of what functions look like. So starting with our base elementary functions, knowing those 6, and being able to apply these simple transformations to figure out what the function should look like at the end of the day is a really useful skill that you'll use over and over and over again, as long as you know how to. So I figure we'll just combine these together. We'll just do one more example. Let's graph y as the negative square root of x plus 1 minus 3. So we'll go through this step by step. We'll start off with the square root of x. There's y as root x. What do I want next, perhaps? How about we do y is the square root of x plus 1. So we'll transform this. Square root of x plus 1, what is that? Well, I'm going into square root of x and I'm replacing x with x plus 1. So that's a horizontal shift. I'm adding plus 1, so it's a horizontal shift to the left 1 unit. So this guy should look like this. So that's minus 1. It's been shifted to the left 1 unit. Now what? Again, this vertical shift, we'll just do it last because I know it's just going to be shifting 3 units downwards. So let's apply the minus now. Let's apply the minus now. So this becomes, we take our graph and we reflect it through the x-axis. So reflecting through the x-axis, we now have a picture like this. And this is the graph of y is minus the square root of x plus 1. And I haven't really left myself enough space. We'll just, how about we squeeze this in up here. Last thing we need to do now that we have a picture of minus the square root of x plus 1, now we just have to subtract 3. So that's a vertical shift down 3 units. So we're here at minus 1 and 0. We're going to shift it down 3 units. Maybe something like this. All right, so there's minus 1. And here's minus 3, and we've got the exact same picture, but shifted down 3 units. And here's the graph of minus the square root of x plus 1 minus 3. So it's really important to recognize, I think this is the hardest part students have, is recognizing that to get this piece, to get the square root of x plus 1, I'm replacing x with x plus 1, so that corresponds to a horizontal shift. Right, everywhere I see an x, I'm plugging in x plus 1 instead. That is the whole section though. We'll stop here.